Dear friends, today we'll discuss a very small chapter of class 12, that is electromagnetic wave. This is a very small chapter of only 1 or 2 periods, and in board examination earlier in CBSE marking scheme, this chapter had the contribution of 3 marks out of 70. Out of 70, its contribution was 3 marks. But now this chapter is combined with optics. Electromagnetic wave is combined with optics, and the whole electromagnetic wave and optics combination gives you 18 marks contribution in the board examination. But still it gives the impression to the teachers that this is a small chapter and its contribution is of those 3 marks in board examination. Though it's a small chapter, but it gives a lot of concept. So let's discuss about this chapter, electromagnetic wave, or in short we can tell EMW, electromagnetic wave. What is electromagnetic wave? If I'll tell you light, visible light, it's a wave. Light is a wave. This light comes from the sun. You have this impression in your mind that this visible light comes from the sun. That's correct. This visible light comes from the sun. But not only this visible light. With the visible light, also heat radiations comes from the sun. They are the infrared radiations which gives you the sensation of warmth. Not only these two, also ultraviolet light, ultraviolet rays are coming from the sun, which are obstructed by your ozone layer. All total, if I'll tell you, many radiations like this comes from the sun, and this will be correct. This sentence will be correct if I'll tell sun provides you electromagnetic wave. Sun provides you electromagnetic wave. So today we are going to discuss about that electromagnetic wave. What is actually this electromagnetic wave? If I will take you to 11th class, you know about wave in class 11th. In 11th, when your teachers told about electromagnetic wave, he classified the wave. When the teacher told about wave, he classified the wave into 2 types: mechanical wave, non-mechanical wave. Mechanical wave, you know, sound wave, string wave, water wave, those who require medium for propagation. But a non-mechanical wave, you must have heard this non-mechanical wave. Best example is electromagnetic wave, because it doesn't require any medium for propagation. Generally, when the wave concept comes to your mind, you think something oscillates and energy propagates. Something oscillates. In water wave, water particles oscillate. In string wave, string particles oscillate. But electromagnetic wave, it requires no medium. So here particles do not oscillate because you have no particles. Particles do not oscillate. Then what oscillates in electromagnetic wave? The name is sufficient. Electromagnetic. So it consists of electric field and magnetic field, which oscillate perpendicular to each other and also perpendicular to the direction of propagation. If I'll show you, suppose this is the oscillation of electric field. This is the oscillation of a magnetic field. Magnetic field oscillate in this plane. Electric field oscillate in this plane. Then the wave propagate in this direction. This is electric field oscillation. This is magnetic field oscillation. And in this direction, wave propagates. Can you mark? Electric field, magnetic field oscillate perpendicular to each other and also perpendicular to the direction of propagation. So, if I draw, sometimes this question comes in exam, to draw electromagnetic wave. So, if this is electric field oscillation is this, then magnetic field oscillation I am showing you in this way, perpendicular to it. I am trying to make it 3D. This is the magnetic field oscillation. And the wave propagate in this axis. This is electric field, this one is magnetic field, and wave propagates. K vector is the direction of a propagation of a wave. Direction of propagation of the wave. Okay, that's called propagation vector. So, this is the electromagnetic wave. If in exam the diagram of electromagnetic wave will be asked, then you can be able to draw this diagram. But here no particle oscillate. I told you no material medium, no particle. It doesn't require any medium. Only electric field, magnetic field oscillate perpendicular to each other and also perpendicular to the direction of a propagation. But this concept of electromagnetic wave first arise in which year? It's not too early. In 1865. 1865, this concept of electromagnetic wave first came to the mind of Maxwell. Maxwell first thought about this electromagnetic wave, gave the idea of electromagnetic wave. Do you know who produced it first? Hertz produced the electromagnetic wave. Hertz produced the electromagnetic wave, and one Indian scientist, J.C. Bose, also produced electromagnetic wave of a different wavelength. Do you know who is the first man who could able to transmit this electromagnetic wave from one place to another place and establish communication? You all know his name, but you know in another way. Who is the first man who transmit electromagnetic wave? You can't able to tell, but you know his name. The man is Marconi, who invented radio. You know from your childhood that Marconi was the inventor of radio. But now you will understand the fact. Marconi first transmit electromagnetic wave from one place to another place, that through English channel. Through English channel, Marconi first transmitted it to around 50 kilometers. Then this is the first step for the invention of a radio. As he could transmit it to some distance, then the radio is invented by Marconi. So this is the history of electromagnetic wave. And now we are living in electromagnetic wave, where we are standing, where we are sitting, around us only electromagnetic wave, everywhere. So now let's come and understand what is displacement current, which also gives the idea about electromagnetic wave. So what is displacement current? This always comes in exam. This question always comes in exam. Displacement current. But before going to that displacement current, we'll see what is the defect in Ampere circuital law? How Maxwell pointed the mistake in Ampere circuital law and gave the concept of displacement current. So modification of Ampere's circuital law. So we see modification of Ampere's circuital law, ACL. How Maxwell pointed the mistake in Ampere's circuital law and how he modified it. It always comes as a 3-mark derivation in board examination. This is a very common question in board examination from this chapter. So how Maxwell explained? So to understand that, let's consider one capacitor. So this is a capacitor. So this capacitor is connected to one AC source. If it is connected to AC source, when current passes through this capacitor, as AC source is connected, so obviously that current is not constant. It's a varying current. Current is a function of time. Current is a varying current. I can't write here I write current is a function of time. It is connected to AC source. You know this one in alternating current chapter, that when DC source is connected to capacitor, then just the time of switch on, current pass, and after few fraction of a second, the current stops here and no current passes through the capacitor. Means all totally when DC is connected to a capacitor, no current passes through it. It's okay. But when AC is connected to a capacitor, then current passes through it. The opposition happens by the capacitor, but still current passes through it. When DC is connected, no current passes. But when AC is connected, current passes. Then the question comes to your mind, how current passes between the two plates of the capacitor? How current passes? There is no connection between them. This is the definition of a capacitor. Two plates separated by some insulating medium. There should be nothing between them. If nothing between them, how current passes from one plate to another plate? How is it possible? This concept is first coming to your mind. So this answer is given by Maxwell. Maxwell explained it how actually whether the current is present between the two plates of the capacitor or not. Maxwell explained it. Let's see how Maxwell explained it. So now you consider a capacitor or capacitance C. It is connected to an AC source. Current passes through it, varying current passes now. Okay. Now take one point P. You will consider one point P here, and I want to find P is at a distance R from this current line. I want to find magnetic field at point P. To find magnetic field at point P, we have to do what? We have to do Ampere's circuital law. So now let's use Ampere's circuital law. B vector dot dl vector is equal to mu naught I. Let's use Ampere's circuital law. So implies that B dl, this is integration, mu naught I as usual, here B dl cos 0 is 1, B integration of dl. This I is a function of time. So B, this integration is 2 pi r. This is Ampere loop. Ampere loop will choose like this. Okay. So mu naught I. Then B is coming mu naught I by 2 pi r. This is the magnetic field formula expression at this point P. when we use Ampere circuit law, choosing this Ampere loop. But if I change the Ampere loop, I change the Ampere loop making a this type structure. How it looks like? I change the Ampere loop, you see. It looks like what? Which type of shape? It looks like a tiffin box. It looks like a pot. I'm not telling my own language, I'm telling the language of NCERT book. It looks like a pot, looks like a tiffin box, where the lead is the previous Ampere loop and the bottom remain between the two plates of the capacitor. Just I change the loop. If we change the loop and again apply Ampere circuit law, again now apply Ampere circuit law here, B dot dl mu naught I in. So this is B dot dl mu naught into 0. Because you are telling no current passes between the two plates of the capacitor, there no current exists between the two plates of the capacitor. The current only passes in this way. If no current passes between the two plates of the capacitor, as there is no connection of wires, if no current passes between the two plates, then I current enclosed is equal to 0 because no current passes here. Current enclosed is equal to 0. So B is equal to 0. Now the contradiction arises. When you choose the Ampere loop like this, a circular loop, at point P magnetic field is coming this much. But when you choose the Ampere loop like this, tiffin box like structure, then the magnetic field at point P is coming 0. This is the contradiction which is pointed by Maxwell. How? When the loop will change, the magnetic field will change. It's impossible because magnetic field at a particular point is constant due to a particular current. So this is the contradiction pointed by Maxwell. This is the mistake in Ampere circuit law. Then how Maxwell modified this Ampere circuit law? Maxwell told current passes between the two plates of the capacitor. This Maxwell told. And how Maxwell now gave the concept in favor of that current? How Maxwell explained the existence of current between the two plates of the capacitor? Maxwell told current passes between the two plates of the capacitor, but how? According to him, Faraday law, if you recall, in electromagnetic induction chapter, changing magnetic flux induce current. Faraday told changing magnetic flux induce current. If magnetic flux changes, then current induce. Then Maxwell demand, if changing magnetic flux induce current, why not changing electric flux? Also changing electric flux will produce currents. This is the concept given by Maxwell. Again I am telling, according to Michael Faraday, changing magnetic flux induce current. Then according to Maxwell, if changing magnetic flux induce current, why not changing electric flux? Maxwell told changing electric flux will also produce current. What happens here? That thing happens here. Here flux changes, electric flux changes. Yes. Between the two plates of the capacitor, electric flux changes. Why? Because you have connected to AC. This current increase and decrease. When current increase and decrease, this capacitor gets charge and discharge. Charge between the plates of the capacitor, charge in the plate of the capacitor increase and then decrease. Increase and then decrease. Because this is alternating current. The current itself increase and decrease. So charge also here increase and decrease. If charge increase decrease, then electric field also changes. Hence, electric flux changes. According to Maxwell, changing electric flux induce current. Changing electric flux produce current, and that current which flows between the two plates of the capacitor is not called as induced current, rather it is called as displacement current. The current which is produced due to change in electric flux is called as displacement current. Maxwell told that current passes between the two plates of the capacitor, called as displacement current. The current which passes in where, that is called conduction current. So conduction current goes, and here displacement current maintains a continuity, and then again conduction current pass. So let's find the expression of that displacement current. So it comes from due to the changing of electric flux. So let's find first electric flux, electric field into area. And electric field is sigma by epsilon naught between the two plates of capacitor. Sigma is A, sigma is equal to Q by A. Surface charge density, A cancel, so this becomes Q by epsilon naught. If I take the derivative of both sides, this is phi 1 by epsilon naught to this side, dq by dt. This dq by dt rate of change of charge, this is called a displacement current. So dq by dt is equal to epsilon naught d phi e by dt. But this dq by dt, that is the displacement current, id is equal to epsilon naught d phi e by dt. I am writing E because E stands for electric flux. As the two flux are now coming, I mentioned phi E because E stands for electric flux here. So this is the expression of displacement current. Sometimes in exam the question also comes, define displacement current and derive the expression for it, as a simple 2-mark question. This part, from this part to this part, will do to find displacement current. After getting the expression of displacement current, how Maxwell modify Ampere's circuital law? Now you see how Maxwell changed Ampere's circuital law. So Maxwell only add in the expression like this, you see mu naught IC plus ID. So ID is the contribution of Maxwell. Then this law is renamed as Maxwell Ampere circuital law. Maxwell Ampere circuital law. The name of Maxwell is then attached in the law. So IC plus ID. So this is IC, in place of ID you can write 1 by epsilon naught, not 1 by epsilon naught, that is epsilon naught d phi e by dt. Then beta dl integration, the LHS side. So now how Ampere circuital law is now will be agree with that our derivation, So in capacitor, outside the capacitor the current exists is conduction current. Inside the capacitor the current exists is displacement current. When IC is there, ID is 0. When ID is there, IC is 0. So one current anyhow exists. There is no chance of magnetic field to be 0. So in this way, Maxwell modified Ampere's circuital law. So this is about the concept of displacement current, what I told you. So now we'll come to the equation of electromagnetic wave. Equations of electromagnetic wave. Electromagnetic wave consists of two fields, one is electric field, one is magnetic field. If you write the equation, you have to write the equation separately. This is electric field equation, omega t minus kx. This wave equation also you know from class 11th. E is equal to E naught sin omega t minus kx, and B is equal to B naught sin omega t minus kx. Minus kx means, always remember, if this is minus kx, wave propagates along positive x-axis. This already you know in class 11th, just but I am repeating this one. I am just repeating, if minus kx is there, wave propagate along positive x-axis. If plus kx is there, wave propagate along negative x-axis. By this you can able to know the exact direction of propagation of electromagnetic wave. Whether positive x-axis or negative x-axis or positive y-axis or negative y-axis. You see both waves have same direction of propagation, minus kx, minus kx. Then electric field as wave propagate along x-axis. If electric field oscillate along y-axis, I let j cap, then magnetic field oscillate along z axis, I let k cap. Or you can also write here Ey, Bz. Ey and Bz. So this is the equation of electromagnetic wave. You have to clearly mention if x is direction of propagation, its oscillation direction, and its oscillation direction you have to must mention. Then what is this k? K is the propagation vector. Its formula is 2 pi by lambda. Omega is the angular frequency. Its formula is 2 pi nu or 2 pi by t, where nu is frequency and t is time period, lambda is wavelength of the wave. And the relation between E naught and B naught, C is equal to E naught by B naught. What is C? 3 into 10 to the power 8. The velocity of electromagnetic wave in vacuum. This is the relation between electric field amplitude and magnetic field amplitude. So this is the equation of electromagnetic wave. Now let's discuss the sources of electromagnetic wave. What are the different sources of electromagnetic wave? Different sources. So the main source of electromagnetic wave, remember, is accelerating charge particle. Is accelerating charge particle. And how this is? Charge particle produce electric field around it. Charge particle, so it must produce electric field. But when it is accelerated, it just behaves like a current, and that current carrying path produces magnetic field. So both electric field and magnetic field combine and electromagnetic wave is formed. So when charge particle is accelerated, as charge particle it has electric field, as acceleration it has, so it behaves like a current, current produces magnetic field, so both fields combine. So the main source of electromagnetic wave is accelerating charged particle. Anywhere it happens, it must emit electromagnetic radiations. It loses its energy in the form of electromagnetic radiations. Whenever it loses the energy, it loses in the form of electromagnetic radiation. Then, second I am telling you, when a high-speed electron bombarded with a metal target, high-speed electron bombarded with a metal target, then also electromagnetic radiations produce. Again, indirectly, we are going to this concept. If high-speed electron will bombard with a metal target, then obviously, suddenly its speed decreases. It gets accelerated. So it produces electromagnetic wave. Another one you already know, in atomic structure of a chemistry, Bohr's atomic model. When electron jumps from one higher energy level to lower energy level, it emits energy in the form of electromagnetic radiations. Lyman series, Balmer series, they all lie to one electromagnetic radiation. So, when electron jumps from high energy level to low energy level in the atom, it also emit electromagnetic radiations. The fourth is in LC oscillation. In LC oscillation, charge oscillates. Means it is oscillated. Also, their electromagnetic waves are produced. So, these are the different sources of electromagnetic waves. Now we will come to the property of electromagnetic wave. The properties of electromagnetic wave. First property, electromagnetic wave travel in vacuum with a speed equal to c. The speed of electromagnetic wave in vacuum is equal to c. And what is the formula for c? 1 by epsilon naught mu naught root over. Epsilon naught comes from where? From electric field. Mu naught comes from magnetic field. What value c you know earlier? It is 3 into 10 to the power 8 meter per second. But today you came to know actually from where this c comes. C comes from this formula 1 by epsilon naught mu naught root over. If you put the value of epsilon naught and mu naught, you will get automatically 3 into 10 to the power 8. If you don't believe me, you can put there and check whether it is coming 3 into 10 to the power 8 or not. Second properties. In any other medium, this electromagnetic wave propagates with speed less than c. Less than c. So v less than c. If any other medium happens, then electromagnetic wave propagates with speed v, which is less than c. So if you write the formula for v, epsilon mu root over. This is for vacuum epsilon naught mu naught. But for other medium it is epsilon mu root over. And this is always less than c. But sometimes one question here comes in exam. What question? Find the relation between V and C. Find relation between V and C. You pause the video here. Try this question if you can. Then after that, play the video and check whether your answer is correct or wrong. So, let's find the relation. V is equal to 1 by epsilon mu root over. But epsilon can be written as epsilon naught epsilon r. Mu can be written as mu naught mu r root over. From where this formula came? Because you know earlier epsilon r is equal to epsilon by epsilon naught. From electrostatic chapter, similarly also in magnetism. So this is epsilon naught mu naught root over by epsilon r mu r root over. So this one is C by epsilon r mu r root over. So this is P. This is the relation between V and E. V and E. Sometimes this comes in exam. So now come to the third property of electromagnetic wave. It's like this. Electromagnetic wave never gets deflected by electric field and magnetic field. Why it will deflect? Because it's not any material body. The body which will have mass, then it gets deflected because force act on it. But electromagnetic wave, there is no mass. There is no material particle. So though it consists of electric field and magnetic field, but electromagnetic wave never oscillate by electric field and magnetic field. Then property number 4. Energy is equally distributed between electric field and magnetic field in electromagnetic wave. Means electric field energy density I am writing half epsilon naught E square. Magnetic field energy density half B square by mu naught. Both energy densities are equal. Energy equally distributed between electric field and magnetic field. Both energies are equal. Let's prove. The question sometimes comes in exam. Prove that UE is equal to UV. Can you able to prove this? Then you pause the video. Don't see further. Now you pause it. Try this question. And now check whether your answer is correct or wrong. So UE equal to half epsilon naught E square. So half epsilon naught, we know C is equal to E by B. So in place of E, you put B into C square. From this it comes. It comes from this. Since. Okay. So E is equal to half epsilon naught B square C square. But what is C square? C square is 1 by epsilon naught mu naught. Epsilon naught cancel. So it is coming B square by 2 mu naught. So this is the energy density of electric field and this is nothing but energy density of magnetic field. Energy density of magnetic field. So UE is equal to UB. Now you got it? This also comes as a 2 marks question sometimes in exam. Then let's come to the 5th number property. 5th number property is like this. Electromagnetic wave obeys the phenomenons, shows the phenomenons like reflection, refraction, interference, diffraction, polarization. So what is diffraction? What is polarization? You will know that in wave optics chapter. But just like your visible light, electromagnetic wave show all these phenomena. This is the property number 5. Then come to property number 6. The electric vector. In electromagnetic wave, I am giving you very important information. You remember, this is a very important information. C is equal to E naught by B naught. But what is the value of C? Equal to 3 into 10 to the power 8. What conclusion you can keep from this ratio? What conclusion is coming to your mind? Electric field is 3 into 10 to the power 8 times greater than magnetic field amplitude. Electric field amplitude is this much times greater than magnetic field amplitude. Means in one electromagnetic wave, the magnetic field is neglected. Its oscillation is very, very small, almost close to the axis of propagation. But electric field oscillation is large. Amplitude of oscillation of electric field is very large. But magnetic field oscillation amplitude is very less. Then the question is coming to your mind that when I draw the figure from the starting, I had made almost nearly equal amplitude of electric field and magnetic field. That I had it only done to explain you, but in real practice, magnetic field amplitude is very less in comparison to electric field amplitude. And what visible effect comes to you? Visible is a portion of electromagnetic wave, this visible light. That is only the electric field. So electric field is also called as optical vector. That gives the concept of visual to you. Electric field. So now come to the property number 7. Intensity of electromagnetic wave. As you know, intensity is the amount of energy passes per unit area per unit time. Let's consider a cylinder-like structure. Let's consider. Suppose electromagnetic wave passes through this. Area of cross section is A. I want to find the energy passes through this area per unit time. Suppose in time del t, electromagnetic wave travels from this place to this place. In time del t, electromagnetic wave travels from this place to this place. Then how much distance it covers? Obviously speed into time. The distance covered by electromagnetic wave is speed into time. If electromagnetic wave which passes in time del t, it is here. So within time del t, how much electromagnetic wave pass? The electromagnetic wave which passes here in time del t, it is here. Within that time del t, how much electromagnetic wave pass? That is equal to this much electromagnetic wave, this much energy pass, which is packed by this volume, cylindrical volume. This much energy pass through this area of cross section. So let's find intensity. Energy pass per area per time. And how much energy is here? Energy density into volume. Energy density into volume by A into del T. So energy density, the volume that I can write A C del T. A, area of cross section, distance C del T, divided by A into del T. A cancel, del T cancel, it is coming U into C. So this is the intensity of electromagnetic wave, where U is the energy density and C is the speed of electromagnetic wave. Then come to the next property of electromagnetic wave, property number 8. This derivation also comes as a 2-marks question, what I did about the intensity. Now come to the property number 8. Electromagnetic wave carry energy and momentum. most important question for board examination. What question will ask in board examination? Justify electromagnetic wave carry energy and momentum. Justify. The answer is clearly written in your NCERT book. You can see, you can underline those lines. How will you prove that electromagnetic wave carry energy and momentum? When electromagnetic wave incident on an electron, it makes the electron to oscillate. When electromagnetic wave incident on an electron, it makes the electron to oscillate. This indicates electromagnetic wave carry energy and momentum. This is the theory of physics. But if we go to our day-to-day life, what is the meaning of this? That something carry energy and momentum. What is the meaning of this? I'm taking you to an example. When some persons do strike, when they do strike, sometimes they forcibly enters some chief minister or prime minister's house. They try to enter, they enter into assembly. What your policemen do? What they do? They use water jet. You all have marked it. They call the firemen and they spray the water jet from where high speed water comes out and strikes those persons' body. And when the water strikes those persons' body, what happens to the persons? They take the rain bath there. They enjoy that water? No. When that water hits their body, they get deflect, they displaced from their original position. They get pushed in the backward direction. Without touching them, by the help of water jet, they push the persons in the backward direction. How those persons get pushed in backward direction? Because the water jet transfer energy to them, transfer momentum to them. So they get pushed in the backward direction because water jet, which is moving with high energy, transfer the all energy to them. The same thing happens in also electromagnetic wave. The only thing in water jet, you can able to see that water is going and striking the person and the person gets displaced. But in electromagnetic wave, you can't able to see that one. If I switch on a torchlight towards you, when the torchlight go and incident on your body, when the light goes and incident on your body, you get deflect. You will be pushed in the backward direction. No. But energy is transferred to you when that light incident on your body. You can't able to realize because you are a huge mass. But energy is transferred, momentum is transferred just like that water jet. But how much momentum is transferred? When electromagnetic wave strikes a wall and the whole energy is absorbed by that surface. I am telling you, the whole energy is absorbed by the surface. How much momentum is transferred? Let's see how much momentum transferred. Momentum transferred P. I am not writing here del P because I am writing P because final momentum becomes 0. Because whole energy is absorbed by the surface. It absorbs U amount of energy it absorbs. Whole energy is absorbed. So P is equal to, so you know from second law, P is del F is del P by del T. So P is equal to F into del T. F into del T. Then what is this F? We know work done is equal to force into displacement. So here force, here work done means nothing but energy. So force I can write here U by D into del T. Then U by d by del t, this is nothing but speed of electromagnetic wave. This is the expression of momentum transfer to the surface when electromagnetic wave strikes and completely absorbed, transferring u amount of energy to it. Also sometimes this comes as a 2 marks derivation in exam. But now you think the answer. If the electromagnetic wave strikes the surface and gets completely reflected, my question to you, if electromagnetic wave strikes the wall, gets completely reflected back, then what is the amount of a momentum transferred? This is the expression when it is totally absorbed, but when it gets reflected back, then what is the total momentum transfer? That is my question to you. So this is about the property of electromagnetic wave. So now we'll move the electromagnetic spectrum. Spectrum, now you see the electromagnetic spectrum. It consists of many waves. So we'll arrange those waves in increasing or decreasing order of their wavelength, and that is called electromagnetic spectrum. So it consists of which waves? Now let's see: radio wave, microwave, then is your infrared, then is your visible light, then is ultraviolet, then X-ray, then gamma ray. Electromagnetic wave consists of these rays, and I now wrote the rays here from top to the bottom in the increasing order of frequency and a decreasing order of wavelength. Lambda decreasing order, frequency increasing order. I wrote the rays from the top to the bottom. Okay, means radio wave is of maximum wavelength, gamma ray is minimum wavelength. Radio wave is minimum frequency and gamma ray is of maximum frequency. Most energetic radiation is gamma ray. But you have to remember what from this spectrum part which comes in exam. You have to remember their wavelength range. You have to remember their wavelength range. Nobody can help you to remember this. You have to mug up the wavelength range. If you remember the wavelength range, then automatically the frequency range you can able to find. Then their production, their detection, their uses also comes in exam. Uses also comes in exam. Production, detection, wavelength range, uses. You will get one table in your NCERT book and you have to practice that table. Okay? So I am just giving you one idea to remember the electromagnetic wavelength range. I am just giving you an idea. If you follow it, you can able to easily understand the wavelength range. You can also able to remember the wavelength range. Radio wave. These waves are used for communication purpose, mobile communication, television communication. They are very long waves. Just have the idea. They are very long waves. They are not dangerous to our body. They are not dangerous. Their frequency is very less, not so energetic. Radio waves. Very long means how much long? More than your scale. Remember, more than your scale. If your scale, what you keep in your geometry box will take as 10 centimeter, so it is greater than 10 centimeter. If I write in meter, so then it's greater than 0.1 meter. Hope you could able to remember. These long waves are more than your scale. They are used for communication purpose. Microwave, you know, they are used in microwave. Also microwaves are used in radar. Why? Because of their, in radar, from radio wave their wavelength is small, and a microwave wavelength is small in comparison to radio wave. Its wavelength remain within your scale. Within your scale means from 0.1 meter to the smallest division of your scale. How much? 1 millimeter. This is the range of microwave. That confined within your scale. 10 centimeter or 0.1 meter to 1 millimeter. As they are of small wavelength, small object size, their wavelength size is just equal to small object size. So they are used in radar. Because you know radar detects objects. The waves go and reflects back. Small objects also it can able to detect. So microwave is used because of its small wave. In exam when question will come, why microwave is used in radar? Because of its small wavelength. Okay. So this is about microwave wavelength range which is confined within your scale. Then come to infrared. These are the heat radiations. But before discussing about infrared, let's discuss about visible that everybody knows. Visible radiation. Visible, you know, visible radiation starts from, they have different colors, 7 colors starting from red to violet. So they have red to violet. They are consists of 7 colors, and this lies between 700 nanometer to 400 nanometer, what everybody knows. This one everybody knows. Visible wavelength lies between 700 nanometer to 400 nanometer. So now let's come to infrared. Why its name is infrared everybody knows? Because red, above red there is infrared, below violet there is ultraviolet. If I split this visible part, here will be red, here will be violet, and in between the other colors lies, but I wrote only G here. So above red infrared, above violet ultraviolet. The names are also given like that. Okay. So red is 700 nanometer, violet is 400 nanometer. Red is of a highest wavelength light. This is. So now infrared range you got 1 millimeter to 700 nanometer. Okay, it's last to its first. Then ultraviolet, where it is used. Ultraviolet. They used to sterilize your instruments what we use for operation in medical. They used to kill germs. They also used to preserve food materials. Ultraviolet ray, you know, they are very harmful to our body. So these ultraviolet rays what comes from the sun are obstructed by the ozone layer. Okay, this also once comes in the board examination. So ultraviolet ray wavelength range is, see here, its last means 400 nanometer to, it's easy to remember, 1 nanometer. Then X-ray. Who don't know X-ray? Everybody knows about it. It is used to detect the fracture in our bone. This X-ray. Okay. So X-ray, its wavelength range is 1 nanometer to, this is 10 to the power minus 3 nanometer. 1 nanometer to 10 power minus 3 nanometer. You also remember one important thing about X-ray. When high-speed electron comes and strikes a metal target, which radiations comes, do you know? X-ray. High-speed electron comes and strikes a metal target, then X-ray waves generate there. Then gamma ray, less than 10 to the power minus 3 nanometer. Less than this 10 power minus 3 nanometer. Gamma ray, which are most energetic radiations, they comes from the nuclear decay process, and these radiations are used for the treatment of a cancer. So these are the 7 radiations which belongs to the electromagnetic wave. So one table is there in the book. You have to remember the wavelength range. I hope now from my explanation you could be able to understand the wavelength range. If you understand the wavelength range, you can calculate their corresponding frequency range using the formula C is equal to nu lambda. C is equal to nu lambda. So today we completed this electromagnetic wave chapter, which is a very small chapter, but it gives many concepts in physics. Thank you.